A lot of students don't come to class now because I post the lectures, right? So I have to record this. Otherwise, I will get complaints. So here is the assignments. We have this one last assignment, application development. I thought maybe we should start looking at that today. Does it make sense? But I also do want to review classes because classes are so hard to understand in the beginning that we need to go over them more. But this other because this other assignment is due, maybe we should start talking about that because it'll take two sessions to talk about the application development assignment. And so this assignment is to write a tic-tac-toe program. So just to play tic-tac-toe with a computer. Then I have this extra credit graphics programming stuff. Is anybody interested in this extra stuff here? Let me talk really briefly about this, and then I'll go back and talk about tic-tac-toe. So, did I have a link to that? I didn't put a link in there. But if you look up here, my notes are, the course notes are maintained in this wiki. So this is an instance of a software development project, and I'm using the wiki functionality for the project to write up our the course notes and the instructions for assignments and so on. But actually, the main purpose of this site called GitHub is to develop software projects, not to host wikis. Right? I'm using it just to host a wiki here. But if you click on this link up here or this tab here, they've got these two tabs. You can look at the code for this project. And I have a folder in here called experiments. And I have two different sort of little tiny experiments just to show how to use this library called SDL, Simple Direct Media Layer, how to use that library to build graphical programs, mainly games. It's a library for making games. This example, Pixels, is it was a little experimental, and I'm not going to recommend that. Maybe the grid example is better to look at. So you can see there's a main program here. There's a main, and then there's a build script. I'll show you what that looks like. There's the C++ command, followed by something that's used to incorporate this library called SDL2, the Simple Direct Media Layer library. So I want to incorporate the library functionality in the program. So we need to do something. When we build the code, we need to say, go get the library code and merge it in with our code, because our code depends on it. And this is, I don't know the purpose of that. Not sure why I have that in there. And then star.cpp, that's a wildcard, so that it matches against any name. So any name followed by .cpp will be included on this command line. So this is the command that runs just like that. And remember how when we call main and main returns an int, we return a 0 to say everything was okay, and we return something that's not a 0 to say there's an error. So if we return a 0, it means that this compilation command succeeded. And this is an AND operation. So in order for this whole expression to be evaluated, the left-hand side is first evaluates the true, and then we need to know if the right-hand side evaluates the true as well. It's just a trick, actually, that programmers use to make the launching of the program .a.out dependent on whether the compilation succeeds or not. See, if the compilation fails, then this thing evaluates to false. And if this evaluates to false, there's no need to evaluate the right-hand side of this AND operation. Anyway, you can think about how that works on your own. So that's the build script. And then there's these, in addition to main, and notice main has lowercase m. It's just code. Just a global function there called main and maybe a few others. But these files start with uppercase letters. That's because these files define classes. They've got grid.cpp and grid.h. Grid.h is the header file. Grid.cpp is the file that contains the function implementations for the class grid. This is what the header file looks like. So you would declare it here, class grid. Don't forget the semicolon right there. The grid has a public constructor that takes an SDL renderer, number of rows, number of columns, and a cell size. So this grid class is used to display a grid of cells. And then there's a draw function. This needs to get called, in your, what's called the simulation loop or the game loop. So maybe your game is running at 60 frames a second. So you call this draw function 60 times every second. And so it's an instruction for the grid to draw itself. And then you've got a function, get cell size. That's just for outside code that needs to know what the cell size is. They can call that function to get it. That's a const. Draw is a const. Then you've got the private member variables. You can see that these member variables match the parameters passed into the constructor. So the constructor is the purpose of the constructor is to initialize the member variables of the object created out of this class. So this is a pretty good review for classes. Now here's the functionality for grid. Notice in this grid.cpp file, that's where we are, grid.cpp, that we need to include grid.h. So we need to, in this implementation file, we need to include the declaration of the class. The declaration of the class describes what are the components of the class, which tells the compiler what we need to provide implementations for. We need to provide an implementation for the constructor, and the constructor takes these arguments. We need to provide an implementation of get cell size and draw, and that's it. 3 functions. And you can see I'm using an initialization list here. There's that colon. And I have the member variable renderer here and the parameter renderer that gets passed in. So do that initialization. Get cell size is very simple. Just return a cell size. The cell size is a private member variable. So we need, if outside code wants to know what the cell size is, it's got to call this function to get it. It's sort of a protective mechanism. We don't want outside code to be able to go in and change our cell size, because that would break the program. So we're just hiding our data, the cell size number. We're hiding that. We're only letting outside code read the value with this getter function. And there's the draw function. So draw, first we draw the horizontal grid lines. Then we draw the vertical grid lines. And actually, I got this. Now, if you want to work on this code, you have to, you got to run it locally. You can't run it in Cloud9. This Cloud9 is just you only have a console interface. You have a text-based interface to the data. You can't run a graphical program like a game on a remote server and see it visually on your local machine. And that takes a lot more data being sent over the internet for that to work. So right now, the way we use Cloud9 right now, we have just a small amount of data that goes back and forth between our local computer and the remote server. So that, in other words, we need to run it all locally. We need to compile it locally, run it locally. Actually, we could compile it remotely, but we have to run it locally. So let me go in there. So there's the experiments folder, grid. Now I started with some other experiment, but I didn't commit that to the repository yet. I go into grid. I'm going to just screen that out. There's the classes. And the build script actually builds, compiles. If the compilation succeeds, then it runs it as well. So it just compiled and then it ran. And I use AWS&D to move this little marker around the grid. And that's all it does, okay? We see grid lines. See those grid lines? Those grid lines are produced by this function right here. Those grid lines are being drawn 60 times a second, because that's the frame rate that I have it set at. So how do you draw grid lines? Well, first you draw the horizontal ones, and then you draw the vertical ones. To draw the grid lines, we need this. We have kind of like a pen. You can think of it conceptually as having a pen. We have to set the color of the pen. So we call this function SDL. That's, it's a library function because it starts with the letters SDL. Set, render, draw color. So we're setting the draw color to white. Oh, here it is. Sorry, this is red, green, blue, and alpha. So the last one is alpha. And the numbers are between 0 and 255. Those are the color components. So once we set the color, we set it to white here. And then we iterate across the rows. Now, like rows, that's how many rows we have in our grid. That's a member variable, see? That's passed into the constructor. We store that as a member variable in the grid. So we can access that value here inside the draw function. That's visible to us in this function. So for each row, we call this render draw line function. It just draws a line. So it's going to draw the line from, from one point to the next. And so if you look here, this function takes us an argument renderer, and then it takes, it looks like an XY pair followed by another XY pair. So draw a line between those 2 points. Well, let's make sure I got that right. I'm going to search on this. We'll go right into the documentation. I will leave this small. So this is the SDL 2.0. This is the website where you can get information and download the library that I'm using. So here's the function. Use this function to draw a line on the current rendering target. So you can render to different things, right? We're rendering to a target. We're rendering into a block of memory, writing data into a block of memory, which is used to be displayed. It's used as a data source for the display. We could write our drawing, the results of our drawing, to another block of memory. Maybe we can create an image We use another block of memory to create. So that's a different target. We have a different rendering target, which is simply an image that we're going to use later on. Whether we'll display it or save it, whatever, it's up to us. So you have this concept of a rendering target. It's a rendering target. You can think of it as just as a like a two-dimensional plane of memory, like pixels, so many pixels wide, so many pixels high. That's the rendering target. It's either going to be an image, or it'll be used to be an image, or it'll be used to render to the display. And so here it is. The first argument is a pointer. By the way, that asterisk, you have to know what pointers are here. That's a pointer to this SDL renderer. And then we've got the points that are defined. This is the from point and then the to point. See, x1, the x coordinate of the start point, and so on. Return value, return 0 on success, or a negative error code on failure. So we can look at, if I do API by category, you'll see all the functions that are provided by this library. There's a basics category. We've got things for initialization and shutdown, configuration variables, and so on. There's a video area, how to the display management of the window, 2D accelerated rendering, and so on. Input events, how to listen for keyboard events, how to listen for mouse events, joystick events, game controller support, the audio interface, how to work with threads, timers, file abstraction, so on. The benefit of using this library is that it's a portability library. So you write your code to perform functions through the library, and you don't care about what operating system you're working under. So your code becomes platform independent. The library is making the different operating systems appear uniform to your code. So you write, say you're writing a game, and you're writing your game in C, C++, and you're using this SDL library, and you can compile to run on a Mac OS X, or compile to run on Windows, or to compile to run on Linux. Those three operating systems your code will run on. Now, it also supports all of the other possible targets, like iOS, Android, PlayStation 3, PlayStation 4, I think it supports. I mean, you name them, Xbox. Lots of, but the library was originally designed as a portability layer for writing PC games, not for mobile devices or consoles. But it does support mobile devices and consoles now, but not officially, something like that. Anyway, I don't promise strong support for that stuff, but it's there. But in my personal opinion, I think the library is excellent for writing PC games. And you'll see, actually, it's the library is used. There's real games that are in the marketplace that use this. What am I going to say now? So that's the draw class. And if you look at how that's used, let's look inside main. A main is going to be kind of complicated here. Now notice these are globally defined variables. This is the window, which is a pointer to an SDL window. The renderer is a pointer to an SDL renderer. The grid is a pointer to a grid, and we define the grid, so we're going to create an instance of the grid class. That's why we have this include grid.h. We create an instance of our own grid class that we just looked at, and use that. And so this is where we have a pointer to that grid instance. And then we have another thing called a player, and we have a player class. We didn't look at that. That's that square that moves around when I press W, A, S, and D, and that square moves around, I'm just calling that the player, right? Because I control it on the player. And this is a generic function, SDL error. I just call that when I detect there's an error, and then I can print. There's this function, SDL get error, which gives some kind of descriptive of the error. We'll just print that out, and then we exit here. See, we exit 1, so we're saying return a 1, don't return a 0. Returning a 0 means everything worked well. We're just going to return a 1. Probably doesn't really help us much, but let's do it anyway. Then main has a draw function, and like inside the draw function, when we call draw in the main file, it sets stuff up. It does this clear. It sets the render color, the render draw color to black. 0, 0, 0 is black, and then we say go ahead and clear the screen with the current draw color. So everything, all the pixels are set to black, and now let's draw the grid. So we call draw on our grid object. Well, notice our grid is a pointer to a grid. It's not a reference to a grid. So we got to use this arrow here to dereference that pointer. That's what we say, dereferencing the pointer. So follow the pointer to where it goes, and I call that draw function. After we draw the grid, then we're going to draw the player. Just in case we don't want to draw the player first and then draw the grid over it, but that actually doesn't matter in our case. And once we do all this drawing, what happens is the drawing is done into what's called a back buffer. So it's a block of memory that's not being used by the video system. We're rendering into it. It's our rendering target. And we do all these draws, and once we're done doing all of our drawing into this back buffer, we do render %, and that swaps the back buffer with the front buffer. So it's double buffered. And now the display system is starting to get its data to refresh the monitor. It's starting to get its data from the new front buffer, which we had just filled in with our draw methods. And that's what's done. This draw method is called 60 times a second in this particular code. This is the basics of a video game. They all do this. This is all basically what it does. All the video games have this architecture. All of them, almost all of them. Then there's another method that just processes the user input. When the user clicks the X button up there, closes the window, that's detected right there in the code. That's the user clicking the X button. And when the user presses the escape key, we're going to terminate the game. And that's detected here. This E is an SDL event. And this E gets filled in. We call a poll event. We pass in the address of E, this ampersand, that's an address of operator. It doesn't represent a reference here. It represents the address of operator. Ampersand has two uses in C++. One is as a reference, to declare reference parameter. The other use is to extract the address of something. So here we're using it in that second form. This extracts the address of E, passes it into this SDL poll event function. SDL poll event function fills in this SDL event object. Oh, let's look that up, SDL event. SDL event, this will be under input events. And let's see if it's in there. SDL event, there it is right there. It's a structure. And by the way, SDL is C. It's not C++. It's C. Remember, C is a subset, pretty much, of C++. So that you can hook the two together very easily. These are the fields of an SDL event. I'm not going to get into those details, but that's what you got to look at there. So when there's a type field in there, if the type field equals SDL key down, and that's a constant defined in the library, It means some key is pressed. Okay, so some key is pressed. Then we do and, e.key symbol dot symbol. If that equals SDLK escape, if it's the escape key, that's a constant representing the escape key, then we're going to return false from this process event function. It just tells the calling code that we're done, shut down. We do the same thing when the user clicks the X in the window here. We also return false. Otherwise, we don't return false, we're going to end up returning true down there. And if we pass through these two tests, then we're going to call process event on the player. We're not going to put in the details here of how the player is going to move. We're just going to go to the player object and say, player object, we looked at this event already. And we're only interested in intercepting a quit event. Well, we didn't get a quit event. So that means we're going to give you the data now. You do what you want with it. The details of how the key pressing of A, W, S, and D, or whatever other keys you want to activate, that stuff is a responsibility that's handled by the player class. See, that's how you break things. That's how you make complicated programs. You've got so many responsibilities. There's so many things to do. You've got to create all these different classes to handle those different things. There are different concerns. The player class is concerned with listening to pressing A, W, S, and D to move the square. That's its responsibility. And this code here should have no understanding of it. We don't want to, we don't want any of that complexity spilling out into this main top level code here. That's why we just call process event on this player class or player instance. There's initialization. This is how I'm initializing. This is where we create a new grid object and a new player object down there. We're using a new operator. We didn't cover that, so you'd have to read up about that if you want to use this code. And here it is. This is called the game loop or the simulation loop. We call process event. As long as process event returns true, we're going to go ahead and draw, and then we're going to delay 50 milliseconds. Oh, I said 60 frames a second, and I lied. It's not 60 frames a second, is it? How many frames a second is it if the delay is 50 milliseconds? It's 1,000 divided by 50. 20 frames a second. Is that right? Well, that's so slow. Okay. Well, anyway, I just wanted to use simple code here. Normally, I have a more complicated code because the draw method takes some time, see? So you're going to measure the amount of time the draw method took. And if you want the frame rate to be some target, like 60 frames a second is around 17 milliseconds. This is milliseconds, by the way, 50 milliseconds. So after you draw, if your draw method takes 10 milliseconds and you want 60 frames a second, then you got to wait 7 milliseconds. So you need to measure. What you do is before you call draw, you capture the time, call draw. When draw returns, capture the time a second time, and then you can compute the difference, the amount of time draw took. And once you got the amount of time draw took, then you know how much delay you need to add on to it to get to your targeted, FPS, whatever it is. That's assuming that your code is running faster than your desired FPS. In the case that your code is running slower than your desired FPS, then that's a whole nother issue that has to be handled differently. And then there's shutdown. You want to do a clean shutdown. All this stuff, if you leave that out, still runs okay. And here's the main function. Look how simple the main function is. You see the idea of functions? We want to use functions to simplify the logic. We init. We have to initialize. Clear. Then we do an infinite loop. Well, we do a loop until some condition is met to exit the loop. Now the user presses the escape key, or the user clicks the window closing thing. But that detail is outside of main. Main doesn't know how the program quits. it just calls this loop, and from its perspective, it's a blocking call. Blocking call means execution disappears into it for a long time, as if it was blocking before it returns. And then when loop returns, we know that the game is over, so we call our shutdown code, and then we return 0. And that's a very simple main right there. This is how you cut things up and make it look really simple to understand. This is the main problem in programming. It's not how to make things run faster. That's a problem. That's an important problem. But a more important problem is how do you write your code so you can read it? Because you need to read it if you're going to make the code do more and more and more. You know, like if you're writing a video game, we're talking tens of thousands of lines of code, you know, for like a side scroller. How many lines of code? I would guess, based on my experience writing games, which is a little experience, not a lot. I would guess a side scroller, like SDL, there's a side scroller I was playing called Shovel Knight. You can buy it on Steam. They use SDL. They're using this. How many lines of code do you think is in Shovel Knight? 40,000, maybe 20 to 100,000, something like that. So we're talking tens of thousands of lines of code for a relatively simple game. So it's all about how to organize the code and make it easy to read. I mean, that's a lot of code to read and manage. So that's the trick. That's the trick, is how to structure your code and so you can build it out. Anyway, that's if you want to play with this and ask me questions about it, you're welcome to do that. You need to, follow that link out, and there's if you want to, you need to what's called clone this. So you need to have Git installed, a Git client installed on your computer, or else you can download it. I think you can download the whole project. Where is it here? Oh, clone or download, see that? So you could download a zip file with the code in it. You can do that. Or you can use the clone command. So I just grab this. And so I use the clone command. I have Git, so it's Git Clone, and I paste that URL in there. That's what it is. It's a URL, and it just retrieves the project. There it is. That's another way to get it. So that's something that it's very dangerous to do that. Don't do this on your home folder. I'm going to kill a whole folder and recursively go through all the subfolders, deleting all the files in it. So you've got to be really careful. I didn't teach this in the class because I didn't want anyone to wipe out their home directories. So that removed the whole folder and all of its contents. So that's that. If you're working on this, you can talk to me more about it. I'll help you configure. The trick is to configure your system. If you're on Windows, you need to use something like Visual Studio. It takes some time to configure that to get a simple build. You want to get a hello SDL program running first. If you're on Macintosh, well, I've got the build script for you already there. It's really simple. Oh, but you have to install SDL, so I can help you with that. And if you're on Linux, it's just like the Macintosh, the same procedure that you use. All right, that's that. Any questions? All right, hope I didn't overwhelm people with that. Let's get back to this application development here. Tic-tac-toe. Now this is not going to be a graphical program. It's going to have to be, we're going to have to play tic-tac-toe with the console. That means we'll print, a grid with 9 cells in it. and tell player go take a move, and then we'll have to type in a number for a cell like cell 2, and then we'll put an X in that cell, so we'll print the next grid with an X in that cell number 2. Then the computer will pick a cell that's open, and then we'll just do it over and over again. So that's how our interface is going to look. But that's your job, is to get that to work. And what I've done in the past, and I'll do it again, unless we decide to do something differently, is I implement Connect 4. And Connect 4 is a game. I show you how to implement Connect 4, and then you just look at the code and use it as a model to implement tic-tac-toe. And where is this Connect 4? You see it there.
Go pro with Oral-B. Oral-B.
4 in a line. Math is fun. Here we go. User's turn. We need to get 4 in a row. So I'm red. I go there, and the computer goes there. Okay, I'll go there. Computer goes there. And so I'm playing against the computer. Oh, it's stupid. Oh no, I'm stupid. All right, let me. I lost. I'm just calling stupid. I always lose. Every quarter I lose this game. All right, call me lazy. So that's what we want to implement. Is we went first. We'll let the user go first in tic-tac-toe. Then then the computer goes. The user goes. Computer goes. Then we determine player's a winner, computer's a winner, or it's a tie. And we announce the result, and then we terminate. All right, let's do that. We can do this in Cloud9 because it'll be a console program. All right. We don't have a lot of time, but we can get started. I can do this in two sessions with lots of explanation. And we'll do it together. So I'll use your input. And I haven't figured out a good way to use classes for this problem. I got to tell you this. If you saw that grid code I showed you, there's a good use of classes there, in my opinion. Well, not great, but okay. We could use classes here. We could use class. Do you want to use classes, or do you want to not use classes for this? No classes? All right. That's the way I usually teach it, and it's hard enough without using classes. So we'll use vector, or maybe we don't even need to use vector. Just IOStream and CSert. I don't think we need it. I don't think we're going to need it. It's better to take it out and just add it in when you discover you need it. Otherwise, we've got CMath in there. Some other programmer looks at it and goes, CMath? Wow, why is he using CMath? I can't understand. Why would connect? And then he's wasting mental energy thinking, trying to figure out why we're using the CMath header on connect. See, we got to cut that out. Don't let code creep into your project that's not needed, because it creates confusion. And it absorbs some mental energy and time. So let's print the grid. So we're going to have a loop where we get the user input and then we print the grid, right? So it'll be some kind of infinite loop, like while true. I'm going to do it like this. While true, we're gonna print the grid. We'll print the grid, and then we'll tell the user enter a move. Okay, and then we're going to enter in the move. And the move will be, say, like an integer. So we have a move, or select a cell. How about select a cell? Something like that. We'll call it the move. And we'll call it the player move to distinguish it from the computer move. And then we just do this infinite loop over and over again. Of course, we have to do other stuff, right? We'll select a cell. So we print the grid, select the cell, right? I did Control C to kill that. So let's do this. Let's print the grid like this. We're going to put it in a function. We're just going to print the grid. So you want to keep this main simple. So we're defining functions that do work for us. So it's a void function, print the grid. And, we're going to print, let's see it. The grid will be like, let's print the middle part. So that's like the middle. So we're going to have two of these. And then we're going to have another one in here that's looks like that, right? And let's have a space. So we'll put the X. We'll put the X like right there. Is that too much space? Maybe it doesn't look good. Let's maybe that's too many spaces. Maybe we only need one space like that. So is that roomy enough? That's too big. Select a cell 3. So we should see an X in the cell 3. So we need to these cells. We have to put like this is say this will be cell 1, cell 2, cell 3. Or do you want to make this? Yeah, the user would need something like that. So we're going to have a grid. And the grid is going to have things that'll look like this. So it might be an X here, and an O there, and otherwise it'll be a blank. So these are characters. So each position can have one of 3 characters, a blank, an X, or an O. So let's have an array of char. And it's 3 by 3. Wait, I'm doing tic-tac-toe. I'm supposed to do connect 4. And this is how you start tic-tac-toe, okay? But connect 4 is different. Sorry. I'm just forgetting spacing out. All right, so let's, in connect 4, we'll have, I guess we can call it a grid. Well, we'll do a grid. And what is it? How many rows do we need? 6. How many columns do we need? 7. 6 rows and 7 columns. So 6 rows, 7 columns. Am I going over? Oh, not yet. So that's tic-tac-toe. So for integer r equals 0, r less than 6 plus plus r. for C equals 0, C less than 7, plus C. So in here, we're going to print. We're going to print what's at that grid position, R, C. And at the end of the row, we need a new line. So let's suppose this grid, we're going to initialize the grid. I'm going to make a function for that. I'm going to do init grid. And for, I'm going to copy this. I'm going to initialize the grid. I'm going to put dots in the grid. Instead of blanks, I'm going to use dots because it's a different problem than the other one. I'm going to put a dot in there. We're just going to put a bunch of dots in the grid. Oh, wait a minute, we don't have to do that. I learned that we can do this. Does that initialize everything to a dot? I think it does, doesn't it? So we don't need this init grid. Let's see if that works. Here we don't select a cell, we select a column, right? Oh, it's only one dot, so that doesn't work. So we should call this init grid. So we'll call init grid in here. Part of the initialization. So this doesn't work. There's our grid. Well, it's not spaced very nicely, is it? So why don't we do this? Oh, thought it was in VI. Control C. I'm using Control C to terminate the program. That looks a little better. So now when I'll pick a column, say column 1. I want to see my X appear right there. Okay? That's a user column 1. A computer, that's column 0. But it doesn't appear there yet. So look at this. If we pick a column, right, in the player move, then I'm going to go grid of 6 column gets an X. But wait a minute, I'm calling that column now because I don't like player move. All right, select a column. All right, I'm going to select column 1. It didn't work. What happened? Look at that. 6. I'm 1 off. The rows go from 0 to 5, right? The row is strictly less than 6. We never let it hit 6. That's invalid. You see the 1 off problem there? So this should be 5. Okay, 1. Oh, That's the computer's one. That's not the player's one. So maybe we got to fix that. I'm going to do column -1. I'm going to convert from human counting to computer counting. Column 1, column 7, column 3. You see that? But they don't stack yet, because if I pick 3 again, it just writes it over top of, so we need to stack them. So now we got to think about having the X start at the top and then slide down to the bottom. And I'm wondering whether we got our numbering right. So here, we're calling this row 0, right? Row 1. Is it better to call, I'm sorry, this is row 0. This is row 1. This is row 5. Do we want to reverse it and make that row 0 here? And make this, row 5, row 4? What do you think is better? What's easier to code this up with?
The way it is.
Okay, we can do it that way. I think it's the other way, but I might be wrong. But I've done this before, so I think it's the other way. But we can keep it the way it is. Let's take a look at it if we do it the way it is. Let's do it the way it is. Also, let's do this. There's no reason, like main is getting too complicated. Let's simplify main. We're going to have a player move. We're going to take a player move function here. And the player move is going to be this. We need to simplify. We need to simplify this main function. We print the grid, then we do the player move. Then we print the grid and player move, back and forth. Later we'll have player move, then computer move, like that, and then we're going to keep adding functionality until we get the whole thing to work. So what is the player move? It's the same thing. Let's just check to see that we got this function done right. Column is not declared. That's because it's up here. That's two, 3. Okay, that works. And now let's do the stacking. So it'll look like this. Maybe we should use 4. 4 row equals, we're going to start in row 5. And we want to stay larger than or equal to 0. And we'll decrement row. See, that's why if we did it the other way, we had 0 to be the bottom, then we would we'd start at row 0 and we would increment r till we hit 5. So this way we're starting at 5 and we're decrementing the row till we hit 0. So which way is easier? I don't know. I'll just do it this way. And so if the grid at position, if the character at position r column -1, you know what? Let's just do this. I'm going to call that C. And then after we read in the column, I'm going to go integer C equals column minus 1. So it's the player choice, the player column. Just to make that, I want to call this player column. This is player column. And then C is player column minus 1. Player column, there we go. So we're just going to work and see. So if grid of RC is a dot, because that's what we initialized it to, then we can do the move. If RC is a dot, then we can assign it an X. See that? Oh, it's got to be R. Now we're going to get stacking. So we find a dot. If we find a dot, at RC, we can put an X there. Otherwise, we've got to go to the next row. Going to the next row means decrementing the row counter because, you know, we're going to look at row 5 for the first candidate position till we look at row 4 for the next possible position, like that. So let's see if that works. Up. R is not declared. Integer R. Ready? Column 2. Oh my God, look at that. Infinite loop. Once we find a spot, we got to break out of the loop. Once we write the X, we're done. We're going to break out of the loop. So we use the break statement for that. Column 2. Column 2 again. Now it's stacking. You see that? Does that look good? All right, we got that working. Of course, we're going to go off the top, right? So I'm still going to, we need to fix that problem. How are we doing here? 106. So do you see how I get started? I'm breaking things into functions. Look at the main. Look how simple main is right now. And it'll need to get a little more complicated, but not too much more complicated. We want to create these functions that have specific functionality that takes care of some responsibility in the program. And that's where we put the details of that job in that function. And then we just move forward and get the thing tested and working. So we'll do that next time. We'll finish this implementation on Monday. Is that right? Monday? Today is Wednesday, right? Okay, good. Did you have a question? I'll just go up? Good? So you don't have to look at the video now, right? Because the video is going to be kind of long. All right.